feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Kahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Woody the Rabbit, and more. Super Statistics Bros.
Hey everyone, how are we doing? Miranda, good to see you here. Jake, good to see you here. Keely, good to see you there. Douglas and Brando. Let's throw out some Mubot points. We're going to start the Kahoot in just a second here. I want to say a huge thank you. Catherine, good to see you here. I know it's a little bit before the exam. The exam's on what, Wednesday? So it's Friday. I got Saturday. I got Sunday. I got Monday. I got Tuesday. I got Wednesday morning. So with that, and Brian bashed his fingers with wave. You didn't know that this semester. Don't hit weights together. Your hands don't like that. So anyways, I want to talk a tiny bit, Dylan, good to see you there, about how to prepare for the exam. So if you're watching this right now, I hope it's a little bit before the exam. That gives you a lot of time. And what you want to do is you want to go to the Exam 3 review page. Now, who knows in the chat how to get us to Exam 3 review? Can anyone put that link? Katie, good to see you there. How do we get to Exam 3 review with Mubot? Alcoa. Oh, dude, Bryant, I was too. Like coming Alcoa from Topside, that area. Like if you go from the airport, like down that road. Yeah, that's exact. Dude, I was stuck on that. I didn't think I was going to get to campus on time. I got here about 6 minutes like to prepare and everything. I left at like 9:10 in the morning. Boom, we got review 3 in the chat right there. Hopefully, Brian, stay safe driving. Only do things if you're at a complete stop. This is recorded, so no worries about that. But yeah, I was totally stuck in traffic too, and I was like, well, if I'm late, I'm late. Oh, it was like, why is Waze telling me to take a totally different route? Oh, it's a traffic jam up ahead. I should have listened to it. I put it on. I was like, why do you put it on? I'm like, because if there's traffic jams, and then I don't do it. Sophia, good to see you there. Let's go look at the review through too. Riley, good to see you there. Drop out, see you there too. Let's do this. Okay, so here's what I want to point out. If I were you right now, and let's put this in the notes. How to review for Exam 3. Then we're going to Kahoot in just a moment. Got all these Adobe Acrobat things coming up right here. How to review for Exam 3 in the notes. Reviewing for Exam 3. Oh, that's awesome. Type all you want then. 5,000 points, Brian, right there. If you're the passenger, have fun. Shouts to your driver right there. Yeah, there we go. So this playlist is one of my favorites. With this playlist right here, I go over all the conditions to start. So let me ask you this. This will be in the Kahoot. What are the first 2 conditions for hypothesis testing or confidence rolls? Does anyone know? I say here, condition 1. What's condition 1? When we do, Miranda knows right there. Nice job, Miranda. Mubot loves some randomness. And then we say condition 2. This playlist is excellent on this. This playlist, I'll show you why. It goes over and it's pretty quick. Some of the videos are a little longer. Let's say it's also the exam review. It's there too. 10%, which means you sample less than 10% of the population by checking if lowercase n is smaller than capital N. It doesn't go into huge detail on because it's a 7-minute video going over all the conditions. And then what do we do? What do we put in the chat when we get to the third condition? What do we say in my class when we get to the third condition? You go, condition 1, random. Condition 2, 10%. And then we pause because the third condition differs by what you're doing. So you can see right here, every single condition listed out. Nearly normal is for quantitative tests. So when you're doing the mean, which is nearly normal for quantitative, you can see it right there. Great job, Tamara, right there. And then then independent means, if there's 2 means you're comparing, because 2 sample t is the difference between 2 independent means. And the chi-square test of independence uses count data, which is categorical data. Sometimes people put the condition first, because if you don't have categorical data, you're not doing count data. You're not doing it. Darius, good to see you there. And then the expected cell counts are greater than or equal to 5. We won't do it exactly 5. Success failures, at least 10 successes, at least 10 failures. Nearly normal can be met with the central limit theorem with a large N of n. So review these conditions. I'd put them on flashcards. It's probably one of the best ways to know them. And then knowing which test they apply to. So another great thing about this playlist right here, I go over the basics of just doing statistical tests, how to write out the null, write out the alternative, find the p-values and things like that, stating your conclusion whether you reject or fail to reject the null. There are written questions on the test where you have to interpret confidence intervals and you have to interpret statistical tests. So if you don't know how to write those out, if you don't know how to write it out, you're going to have a bad time. We'll do one right now, and I'd suggest watching these videos right here. These are basically mini lectures behind me right here. So you can see the t-test right here. The t-test, Mubot's putting some confidential interpretation in the chat. It goes through, it shows you all the notation. So if you go to the formula sheet, has anyone ever been to the formula sheet and you're like, what in the world is the notation? Has anyone like gone to the formula sheet and they're like, I don't know the notation. What is mu naught? It's the hypothesized true mean. So if you go to the formula sheet right here, formula sheet, which you can print off and have for the test, go to the exam formula sheet. You can see everything right here. Here is the t-test. That's the t-interval, excuse me. Here is the t-test. And then you can see me going over everything right here, notation-wise, writing out a problem, and then giving the equations. So I write out the full equation, do the null and alternative. I find the difference. I talk about the nearly normal. I solve for the t. There's the equation. What is the top of every test, basically? It's a what? I'm just doing a quick review right here, then we're going to do the Kahoot. The top of every test is basically a what. You're finding the what at the top. Like when you look at all the tests, like this is a test. This is a test. Even down here, this, well, that's the interval. This is a test, this is a difference. And even over here, this is a test right here. So it's kind of interesting how the theme of each test takes a difference, and then we whatize that difference. Every test takes a difference, and then whatizes that difference. And that's not SD times P hat. The SD P hat is that over there. We take the difference and we whatize it. We standardize it. Great job, Catherine, right there. And I like to write the full thing out. I usually don't write that the standard error is this. In the notes, it says like this is the standard error. So I just write the sample mean minus the hypothesis mean over the standard error, which is s over square root of n. So I just solve it all out. I solve the equations. And down here at the end, you can see I find a t-statistic. What's my t-statistic? I'm finding the p-value right now, I believe. So it looks like we are doing, let me ask you this question. Did we do a less than, greater than, or not equal to test? Just look at the graphic. If you don't know the answer to these, we'll be reviewing here in a moment. That's what we're going to write out in a second here, Riley. Did I do a less? Boom, Douglas knows instantaneously because the does not equals shades both sides of the curve. And great job, Jay, right there, too. The not equals to test, the sign of the alternative dictates which way you shade when doing your test. Unless I'm just explaining things. Nope. We did the does not equals alternative. The null has the equal sign. What are the three? And I'm giving you some possible test questions right now. It's another teaching to the test moment. What are the possible three alternatives that can be for the sign of the alternative? I'm kind of trying to make it. What are the possible three alternatives? The three possible signs, which means less than, greater than, not equal to. Boom, Catherine and Douglas and Miranda know the three alternatives. The null has the equal sign, and the only thing that changes when you write a null and alternative is the sign. So even if you go to any of the other tests you see me doing, like the 1 proportion z test, the only thing you're going to see me change right there is the sign when I do a greater than test, which means we're going to shade to the right. So if you go here to the very end of this test where we found the p-value, you can see we go to where the z-statistic is and shade to the right because it's a greater than test. So remember, the sign of the alternative dictates which way you shade. Now, how would you write out? Let's say we're testing if more than 50% of students want a Taco Bell on campus. So we're trying to figure out if more than 50% of students want a Taco Bell on campus. This is going to be a lot to write, but this will see if you can write out. And we're going to use the classic 0.05 alpha. So Mubot's going to put this in the chat for you. And if you haven't written down both of these yet, I'd write down what Mubot's about to say. I'll pin the hypothesis one, but think about this. What would you write when you see this test right here? So you can see the result of the test right there. And Mubot's got, I'm going to pin the hypothesis one. We're going to do the Kahoot in just one moment. But I just want to point out the power of these videos and then trying to do this with the video, trying to write out like you would this test right here. You have to think, well, what am I testing? I'm testing the proportion of students who think we should have a Taco Bell on campus. The null hypothesis is 50% of students want a Taco Bell on campus. I am examining for evidence that the true proportion of students who want a Taco Bell on campus is greater than 50%. My p-value came back as 0.0002. 0.002. My p-value came back as 0.002. So now you have to figure out how to write this. So when do we reject the null? This is the first part of what you see in the chat. We reject the null when the p-value is low, or than alpha. Alpha is 0.05 unless otherwise stated. So we would state, how do we do it? I want to see some people start writing it. Because if you can write this in the chat with the prompts, you'll do better on the test. Try doing it on paper. Try doing it. The more you say it, the more you think it, the more you do it, the more you can do it on the test. We're going to start Kahoot in about 3 minutes. Who's got it? Anyone? We'll throw some points. Remember, we're testing the true proportion of students who want Taco Bell is greater than 50%. That's what we're looking for evidence for, with the hypothesized proportion equal to 50%. What would you write? I know someone's writing it out right now. I can feel it. They're about to hit enter. They're going to hit enter in 3, 2. Okay, 1. They're hitting. Oh, there. Jake on fire. I reject the null that the true proportion of students who want to Taco Bell on campus is 50%. Make sure to say the null that it is 50%, that the true proportion who want to Taco Bell on campus is 50% because my p-value 0.002 is less than alpha. This means I do have evidence for alpha. It's Jake, yeah, I think you're word limited, you're word locked right there. I think Jake's doing a great job right there. This means I have evidence for my alternative that the true proportion of students who want to Taco Bell on campus is greater than 50%. So you look at what Jake did right there. I'm going to say it one more time. I reject the null that the true proportion of students who want to Taco Bell on campus. And you can actually just look at the null while you're saying it. Just think, I reject the null that the true proportion of students who want to Taco Bell on campus is 50%. Because my p-value of 0.002 is less than, Riley's got some good stuff right there, is less than 0.05. My p-value is way less than alpha, which is a 0.05 unless otherwise stated. Make sure to check problems. We do say use this alpha, so look at the alpha. And this means I have evidence for my alternative that the true proportion of students who want to Taco Bell on campus is greater than 0.5, 50%. So really good work right there. So here's what I beg of you. Please check out Review 3. It's got a lot of great materials. You've got the speedrun videos. I know a lot of people really like the speedruns. If you go to like more on tests, this has type 1, type 2 errors, which we will go over. There's me doing the classic. In a type 1 error, even long hair Brian right there. In a type 1 error, the null is true. In a type 2 error, the null is false. Oh, wait, a type 1 error, the null is true, and we reject it. In a type 2 error, the null is false, and we fail true. I don't even know what I'm doing on the screen. Who knows? Oh, there we go. In type 1 error, the null is true, and we reject it. In a type 2 error, the null is false, and we fail to reject it. I'm going to talk more with my hands right here and do the type 1, type 2. So check out these videos. It's the way I've taught for a while, even though I made these videos in Texas. But I do suggest, and you can watch test review videos here going over the questions. No, Darius. It's because Hannah came up with it, and I was like, that is perfect. So you can see I visualize everything for you. End of advertisement for the videos I've made. I hope they help you study. If you're wondering anything on the exam, it's there. You know what it's time for? It is time for Kahoot. Let's do this. Let's put a thing in here. We'll start the Kahoot in about 1 minute right now. But let's do this at the 16:23 mark. Start of Kahoot. So that was our little 10-minute advertisement for check out the study material. Lots of great stuff right there. Kahoot code's on the screen. We're going to Kahoot. There's quite a lot of questions in this. I don't know. Which more questions? We'll find out. How many people do we have watching? Mewbot's in the chat. How many people we got? 44. Cool. I know it's so early before the test. Thank you for being here. Remember, there is $20 Amazon or Starbucks gift cards. I didn't ask for the email since this is open to everybody. This is open to everybody right here. So we're just doing it as a, fun day. So, did it ask for the emails? If it asked, that's all right. If it didn't, I thought I didn't click it. So, it's Anakin Skywalker, is it? That's what I thought. I've seen that all semester, Darius, and I'm like, it didn't. Okay, that's what I thought it didn't. I was thinking it did not. So, did not. But the thanks thing. We're playing on we have one of the best islands ever. We'll start in about 20 seconds, so join in. Don't worry if you get things wrong. Stay the whole time if you can. Tell people to watch the video. We're going to review each concept that we get right or wrong. And the more people get it wrong, usually the longer we stay on the concept. Remember, we can only do so much during the Kahoot. On the test, you have multiple choice. You have true, false. You have all different things. Dude, Brando, 5,000 points. Yeah, it's like new features. They've done really good at expanding what Kahoot can do. So I'm gonna try to use Kahoot even more. It's one of the better platforms for like helping students. Oh, I know, right? I'm gonna keep it, Darius, for next semester because I want to make like a level 100 island. Like I'm such a completionist. Watch next semester be like, this is not our island, this is not no. And you guys be like, get them off our island. The stats on island will continue, I think. I want to grow it more. Is that a good idea? Like I want a level 100 island. I just want to see what happens. Keep playing Kahoots. Okay. I think it's time, everyone. Let's grow it. I like Darius. I agree. Could you see our top pick, Tommy? Let's do this. Time for Kahoot Best Island ever. Here we go. Welcome to our island, everyone. It won't be a lonely island. 3, 2, 1. Let's go. How would we test if there's a relationship between being a married student and non-married student and your age? Now, this goes to things like the tools and techniques, and I have seen test questions like this. Now, write down what each one of these does. You ready? So while you're answering this, if you haven't answered this, I'm going to tell you what each one of these does, an example of when we would use it. I want a marking. That's so cool. Great job. The chi-squared test of independence has a condition called count data, which means you have to have two categorical variables. So that would be like, do you live on or off campus and do you own a pet? See, on or off campus, like on, off, do you own a pet? Yes, no. The one sample t-test tests one mean. What is the true age of students on average? Categorical. Darius is right. This is categorical. This one over here is just one quantitative y variable of interest, like what is the average age of students? There is no bivariate to the one sample t. It's just one variable. Same thing with the one proportion z. It's one sample, one proportion z, often called. And that would just be what are the proportion of students who like Taco Bell? It's a categorical question. And the two sample t. Really good job on this. That's a lot of people who got it. The two sample t, the reason it's called two samples is because you're comparing two groups. And what are you looking for with the two sample t? In the two sample t, write this down, you are trying to analyze the what between the two groups. In the two sample t, which is right down here, in the two sample t, you're trying to analyze the means. And yes, because the t means means. Whenever you see t, it does mean means. And you're trying to analyze the difference in means. Because the t, and that's right, the t means means. If you see t, it's associated with the mean. Because, z is not. Z is with proportions. So when you see means, you'll also see the t. And then the two sample t analyzes the difference in two means. That's different than a two-sided test, which deals with the hypotheses. So be very careful. I've had people say, but what's a two-sided test? Well, that deals with an alternative that is a does not equals alternative. So the two sample t compares the difference in two means. This top equation right here is when you would try to figure out if the true proportion of students who like Taco Bell is 50%, categorical questions. The second one would be if you're trying to figure out the average age of just students here at the University of Tennessee, one sample mean. The second one would be if you're trying to compare the age of married students and unmarried students, comparing the difference or estimating what the true difference is. The last test down here, the chi-square test of independence, is when you're trying to figure out things like, hint, whether or not students own a pet, categorical, and if they live on or off campus, categorical. Nice job, Darius. You are correct. The one-tailed tests are the greater than or less than because they only shade one side of the curve. So when we talk about the sidedness of a test, that's not the same as the samples of a test. The samples go to how many groups we are analyzing, which is like one group compared to another, two sample, versus the sidedness goes for the alternative. We oftentimes, everything you would need on the test is given to you, like calculating exact p-values will not be on the test. Let's do the next question. Here we go. Leaderboard, Majestic Iguana, Captain Possum, and Purple Rabbit. How can we test a relationship between someone owning a pet and if they are married? Hint. Okay, so this should be a little bit of a review question. And the big thing right here is to know the variable types. Once again, quick review. Two sample t-test. Try to come up with your own version of it. Who can in the chat tell me when you would use a two sample t-test? Maybe it's in your field of study. Like, you can tell me your field of study and I'll come up with one, or try to come up with one for your field of study. This answer is not a two sample t-test. But tell me when you would use a two sample t-test if you've already answered the question. Just think about when a two sample t-test would apply to you, or tell me your field of study and I'll give you an example. I'll wait, I'll see what they say. The answer is not two sample t-tests. because of variable types. When would we use the two-sample t-test? Anyone's field of study? Finance. Oh my gosh, you're comparing like two stocks over time, like stock A versus stock B, because that's finance, right? Like, or two investment methods or something like that, like investment method A versus investment method B, and on average, which one makes more money? Because you're just comparing the means of two groups. So the two-sample t-test, you'd compare like investment method A, investment method B, and compare it. And income of homeowners and non-homeowners, exactly. It's because two groups is you have homeowner, non-homeowner, and then some quantitative metric they're compared on is the two-sample T. So understanding like you have two groups, homeowner, non-homeowner, that makes it the two, and then the T or the two-sample is homeowner, non-homeowner, and then the T is mean. Compare the means of the two groups. Chi-squared, once again, is two categorical variables, which this applies to. The condition called, what is the condition for two categorical variables that the chi-squared has? Review question here, which if you know that, you'd know the answer. Correct, Riley, and then I'll answer Riley more in depth here in a second. What is the condition for the chi-squared? And Darius has it. It's called count data. So to Riley's question, a really great question, Riley. I'm going to bring up the screen right here. If we have two quantitative variables, what are we doing? If we have two quantitative variables, what are we doing? So Riley, if we have two quantitative variables, what are we doing? Once you see it, you'll know it, and you'll be like, oh yeah. If we have two quantitative variables, what are we doing? Scatterplot, regression, correlation. So on the right here, you see scatterplot, regression, correlation, which is two quantitative variables, QQ, straight enough, no outliers, plot doesn't thicken. But it might only be Ford cars. Oh, I can do the title status. Here is a two-sample t-test, and we can go right here and do t-test. And there is the two-sample t-test output. Is there a difference between the average selling price of a clean vehicle versus the average selling price of a vehicle that does not have a clean title? Is there a difference in the average selling prices? Is there a difference? Is there a difference? Oh, yeah. The difference is $16,000. And think since the difference is negative, clean vehicles on average, I know that's the median, but clean vehicles on average are selling for $16,000 more, and this difference is ridiculously statistically significant. That's a does not equals test right there. Very important. That's the does not equals. That would test that. The second one would test that the salvage title sells for more, which we don't have evidence for that. And this one would test for the salvage title selling for less than. And I want to just show this very quickly. With these alternatives, you can actually plug them into here. When you get this sample for the two-sample output, if you take this less than sign and plug it in right here and write mu salvage less than mu clean, does everyone see how this would test the alternative that the mu salvage, the true mean of salvage vehicles, is less than the true mean of clean vehicles? Just ignore the minus sign here because I'm just pretending we put the sign right there. So you have evidence for that salvage vehicles sell for less. Rotowave bomb, what? Oh my gosh. We said it, we're gonna do it. We're dropping 50,000 points for Rotowave bomb. I want everyone to give a huge shout out. Rotowave is graduating. I saw Rotowave last night. So everyone, 50,000 points, Rotowave bomb. He had it in his calendar. Absolutely love it. Hope to see Rotowave in the future. 50,000 points dropped from Rotowave right there. Jumping in. Give some W's and congratulations on graduating right there. Huge shout outs. I'm so happy and sad to see my students graduate. But Rotowave, good to see you here. Swing by anytime. I said I was going to do it. So I'll be back. I hope to see you back. All the way from 201 to other classes, classically here. And Rotowave got to had my class when I was in Texas, and then I came back. So now I've been back for like 2 years. So, man, let's do the leaderboard. Majestic Iguana, Classy Leopard, Elated Newt, where's the bunny? Good to see you, Magic Wombat and Winged Squid. Next question is, when doing a hypothesis test on the mean, which is a condition that must be met? Condition 1, random. Condition 2, 10%. Then we pause, and you got all the remaining conditions. When you hear a test on the mean, you're doing a what test? When you're doing a test on the mean, you're doing a what test? When you're doing a test on the mean, you're doing a what test? Boom, t-test. Jake and Darius know a t-test. So it's not success failure, because success failure is for proportions. That's at least 10 successes, at least 10 failures checked by NP hat or NP nod, NQ nod, NP hat, all the good stuff. Could be one single T or it could be two. Yeah, I guess you just say on the mean 5,000 points Tamara, because I didn't say on both means to check their difference. Tamara, very specific and very accurate. Count data is for two categorical variables, which is chi-squared test of independence, and the expected cell count is also for chi-squared. That means when you're doing the test on a mean, it's a t-test, and you're doing, I can't reach it, the nearly normal. Success failure is for proportion. It's the first condition we learn. I highly suggest take a moment, if you haven't done this, and recreate this grid and make it look more pretty. Did anyone write these down besides me? Has anyone written these down? I bet if you wrote these down, you got it correct. But write down these conditions right here for categorical, quantitative, and categorical. Two sample T is categorical quantitative, but the main thing is you're analyzing a quantitative variable, the mean of it. So if you write this down, it's going to help you memorize it and get it right. That's what happens when we memorize it. But these are the conditions that come after random and 10%. Know which ones go with which. Expected cell count and count data are chi-square test of independence. Success failure, at least 10 successes, at least 10 failures, is for proportion, interval, or test. And nearly normal is for quantitative t-tests. Leaderboard, majestic, iguana, classy, leopard, magic, wombat, bronze, bat, and aquatic bear. Let's go. Which condition do we need at least 5 of? So you need at least 5 this. What will it be? And I think we know how to do this condition in our head. I try not to block answers. I think we know how to do this condition. Imagine I tell you this. Let's say there are 2,000 people at a party. 2,000 people at a party. I'll make it easier. There's 1,000. Scratch that. There's 1,000 people at a party. And of the 1,000 people, you know half the people there. So you know 50%. Like, you know how, you know everybody. And there's 20% of the people are athletes at the party. Okay. How many people would you expect to know who are athletes? How many athletes would you expect to know at the party? Who knows? We'll see this in a moment here. I'll draw it out. But how many athletes would you expect to know at the party? How many athletes would you expect to know? The answer is expected cell count. Close. 100. 10%. 10%, 100. Great job, answers in the chat. Let me show the math on this and draw it out. So you are expected. There are test questions. I think I have some in the Kahoot right here that ask you to find. Let me make sure I got everything. I think we're good to go. Okay. Go away. Okay. What I'm talking about right here is if you were to say, I can actually cheat. Watch this. Boop. I forget I can do this. Thank you, Haslam, for all of my cool tech. There's 1,000 people at this party. Half of them are people you know. And then there's 100 or 10% athletes. So what you do, what is the formula to get expected cell count? What is the formula? If I were to go here and say, well, how many, if we have here, I know them, I do not know. And then they are athletes, they are not athletes. It kicks. You can join back in, Keely, right there. I'll have this code back on the screen in a moment. What is the formula for how many we expect? Boom, boom, right there, Ellie. It's going to be row total times column total over grand total. That is on the formula sheet. So you merely take the row total right there, you take the column total down here, and then you take the grand total over there. And you literally make a crosshair on it. You go like this, like that, and you circle them. You multiply, you make the screen go crazy, you divide. So you're literally taking 10% of 50%, giving you the answer. So mathematically, it kind of makes sense. And you just go here and you do 100 times 500 over 1,000. And that's the expected. Is that right? Ooh, did I get it wrong in my head? Did I change my numbers? I think it's 50. We said 100, but no, it makes sense. You'd know half the athletes, right? Does that make sense? If there's 100 athletes, so it is 50. You'd expect to know half the athletes. If what you have is not associated with who you know. If it's just they're independent. This is the chi-square test of independence. So it is 50. Sorry, I was doing it in my head too, and I was like, is it 100? I was like, 100 sounds about right. But it would be 50 for via mathematics. And then does it make sense? If you know half the people, you'd expect to know half of the 100 athletes. I mean, just that makes sense. So it makes sense when we look at it. It makes sense when we solve it. Oh, let's go back here. Oh, I said 20%. Catherine correcting me right there. I did. Oh, there we go. And I said, Catherine, what am I doing? Jake's right. Jake, sorry about that. 10,000 points in the chat. I think I looked up and saw Catherine's answer and then saw, I don't know. I need my third cup of coffee this morning. Let's take a look at that leaderboard. Here we go. Via that mathematics, it was correct. And via the original answer, it was also correct. Majestic, classy, and social. Good job. Here we go. Which of the following must be true to meet for the chi-square test of independence? So this is all just over conditions. Really good practice on the conditions. Make sure you know what the conditions mean and how to check them. Some answers are just as straightforward as asking you which of these is for the chi-square test of independence. First two conditions are always a gimme, random and 10%. We're not doing QQ straight enough, no outliers, plot doesn't thicken anymore. That is the conditions for correlation and regression if you had plot doesn't thicken. And when you do the chi-square test of independence, you have to use two categorical variables. You have to be using two categorical variables. You need at least, remember we just did expected cell counts. So that graphic you just saw me making a second ago was literally calculating expected cell counts. So row total times column total over grand total, which is a formula given to you. And it's on the formula sheet. It literally says expected next to the chi-square test of independence. So when you're like, oh, what are the conditions? There's the thing that says expected cell counts calculations. So I want to always show you how the formula sheet can help. Does everyone get right here? If you go to this right here, what do you see right here as part of the chi-square test of independence? What do you notice? Just say it with me. Just point it out. I mean, I've already said it 10 times. I just want you to acknowledge, wait a minute. The chi-square test of independence literally has you calculate the expected cell counts. So wait a minute, that expected cell counts greater than or equal to 5 is related to the chi-square test of independence right here, and this is the chi-square test of independence. So, and also, the null hypothesis has the word independent in it. So good memorization. Great job, Tamara, Riley, and Douglas, and Darius. Here we go. Good job on the two answers. Success failures for categorical data, nearly normals for quantitative data. Roshni, excellent work. Here we go. Classy Leopard and your bunny. I love it. Next question. The chi-squared test statistic is found how? This is also on the formula sheet. We're talking about this value right here, which is the Pearson chi-squared test statistic. This is on the formula sheet. So if you're watching this right now, go to the formula sheet and see if you see the answer. The chi-squared test statistic, not the individual cell chi-squareds, which is part of it. I hope we do really well on this one. It is straight on the formula sheet. So when you think about how do you find the chi-squared test statistic? 100% just right there. And basically a cell chi-squared is kind of how weird our data is. So a cell chi-squared, yeah, exactly. Nice job, Darius. I guess if you're in 207, I can bring it tonight. I can bring some formula sheets tonight. If you're in 207, because we have an in-person room for 207 if people wish to take it tonight. So 207, 201 are here. 207, the honors class, they do an in-person test or they have a room reserved for that. They also have it open till it's there on different dates, different schedules, different class. So, but make sure if you're in 201 to print off your formula sheet, write it down, and don't include anything else. It can only be the formula sheet. Good question, Miranda, right there. It is summing the cell chi-squareds. Vol Stacy, thank you. Darius, awesome advice. We're going to throw Darius another 10,000 points on top of that. Or I put 50,000, but I'm going to do 10. I don't know. I should give the 50, right? Thank you, Darius, for that great advice right there. It is the same classroom, same bat channel, different bat time. And you can see right here the sum of the cell chi-squareds. Each of these is a cell chi-squared. So you sum up for each cell the chi-squared, and that is the test chi-squared right there. Test chi-squared. Okay, here we go with the leaderboard. Remember, if you win first, second, or third, send me that email. Also, keep playing. Remember, if you're getting it wrong, you're learning. Majestic Iguana, Classy Leopard, and Captain Boa. Next question. What is your decision regarding the null? Anyone want to say a bad word in the chat? Because Darius likes Darius has got some good hints in the chat. Because I bet Darius is like, and other people are like, wait, I got this. What's a bad word? If you know, you know in our class. If you know, you know. Oh, Miranda. Oh, yeah. Darius, thank you, Darius. Mubot's not going to get so mad. We got a bunch of bad words in statistics. Prove, cause, accept. Those are bad words. We don't like them here. I'm trying to think if there's any others I've programmed Mubot to get mad about. We don't say we accept the null. You do not accept the null. We don't prove things here. We just have evidence of things. So we do not accept the null. We do not accept the alternative. We don't prove things here. We only show evidence of things. What do we have to show evidence for, the null or the alternative? Type it in the chat. Do you show evidence for the null or for the alternative? Which of those do you show? Bama going to lose. Do you show evidence for the null or the alternative? You show evidence for the alternative. The null is believed without evidence, so the null is just a statement of current belief, like, I think I can run a 4-minute mile, till there's evidence to show I can't. Yeah, I can't. So you either reject the null or you fail to reject the null. How do I like to talk about failing to reject the null? Because my wife says, did you get the stuff at the store? And I say, I failed to get the stuff at the store. Good question, Riley. We'll show that. And Dylan's given. So you either reject or don't reject. I like to say for fail to reject, don't reject. It's just that we have to teach you fail to reject because people say it. Because it's taken hold in the lexicon. It's, yeah. We wouldn't say we have evidence the null is true. We'd say we did not have evidence for alternative. I think there's a Pearson question I don't like that kind of says, like, we have evidence to retain the null. You would just say, I didn't find evidence for alternative. Like, I still believe the null, which means retain the null. That's another lingo we sometimes use. I like to say I don't reject the null. Classically, fail to reject. The okay way to say this one is fail to reject, very classical way. Do not reject, Brian's way. Retain the null. Some people say that. Reject the null. Pretty much everyone says I reject the null, or like I have evidence the null is false. Evidence for the alternative. Question on why did we fail to reject the null? Good question. When the blah, 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 when the blah, 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 the blah, 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 write it down. Someone's going to say it in the chat. Darius has kind of already said it. So I want people to say it. I want you to remember it because I can say it a lot. When the p-values, what? When the p-value, so you always want to look at the p-value. P-values are probabilities. When the p-values, what? Write it down if you don't know it. When the p-values lower than alpha, which is assumed to be 0.05 unless otherwise stated, when the p-value is low, reject the null. When the p-value is higher than alpha, just let it fly. So when the p-value is low, we reject the null. When the p-value is high, you just let the null fly. And it's a rhyme. What does let the null fly mean? It just don't do anything to it. Just let it fly. If someone says, hey, should I, you cool with this? Yeah, let it fly. Does that make sense? When the p-value is low, the null must go. When the p-value is high, let the null by. It works too right there, Will. Great job, Will. I like that in the chat. Let it fly gracefully. Exactly, Darius. So when the p-value is low, reject the null. When the p-value is high, just let it fly. There you go. And it's that p-value right there. It's not lower than alpha. P-value is higher than 0.5609. And let me ask you this. Or I'll just say it. Remember, you might have to write out your results. We'll practice that more as we go on. Is there a higher p-value than what would be the answer? If there was here's what you would do on a test very specifically. Imagine Brian is testing the alternative. Do you see this right here? We're testing to see if salvage vehicles have on average lower titles. Type your conclusion right here. We're testing to see if on average a salvage vehicle has a lower sell price than a clean title. What would be your conclusion on this test? What would be your conclusion on this test? What would be your conclusion? Your conclusion would be what? We're testing to see if on average a salvage vehicle has a lower selling price than a clean vehicle. What's your conclusion? What's your conclusion? You can just tell me the word or words. You're testing this right here. Whoops. Really? I want to write. There we go. You're testing that. I've already done a lot of the work for you. And I mean, use an alpha classic. So what's your conclusion? Just tell me the word. Reject the null. Exactly. That's what I'm looking for. Just that right there. So my p-value of 0.0001, I reject the null because my p-value of 0.001 is way less than the alpha of 0.05. This is extreme evidence that a salvage vehicle's title on average sells for less than the clean vehicle title. So you can say I reject the null that the clean vehicle title and the salvage vehicle title have a equal selling price because my p-value of 0.0001 or less than 0.0001 is less than my alpha level of 0.05. I reject the null because the p-value is less than alpha. This means I have evidence for my alternative that the clean vehicle title, you could say, sells for more, or the salvage vehicle title sells for less. Does that make sense, Riley? So you always look to this right here, whatever the p-value is, and then you compare it to alpha. When the p-value is lower than alpha, I reject the null. When the p-value is high, you just let the null fly. Why don't use the probability greater than? Good question. So what that would change is the sign of the alternative right here. You would then be testing to see if the salvage vehicle sells for more. And since the difference is negative, you really don't have evidence for that. So if someone said, I think salvage vehicles sell for more, I want to see if there's evidence for that, they could do this. There wouldn't be evidence, though. So that would be changing the way the test is done. Notice how I just take, you can easily, with this output right here, just take this and plug it into there the way the sign goes. Does that make sense? You just remove the equals, which is the sign of the null, and then you plug in the sign right there. And this is checking for evidence that the salvage vehicle on average sells for more. Just read it across right here. Is there evidence, because it's the alternative we've written out here, is there evidence to the alternative that a salvage vehicle on average sells for more than a clean vehicle? No. The p-value is very high. We've let the null fly. There's not evidence of that. So good questions right there. It just depends on the researcher's question, which is the sign of the alternative. Hey, Hayden, good to see you there. And Riley, good questions. Let's do the next question on the Kahoot. Please keep asking questions. That's the point of this. The Kahoot's for fun and for learning, but your questions are what matters. How many degrees of freedom does the test have? Let's see if you can get it. Okay. The answer is on the screen, technically. This is a what by what. This is a what by what. Darius is quick right there. You're fine. How do we find the degrees of freedom on the chi-squared? This is a 2 by 2. And shout outs, I think it was Douglas or someone in the chat, because they said just bring your hand in like this. And do you see it? What is the formula now? And Douglas, great job right there. I think, was it you, Doug? It was Daryl. It was Daryl in the chat. 5,000 votes. It was Daryl. Because I say drop the fingers and multiply. Drop the fingers and multiply right here. So with this right here, drop fingers and multiply is what I say. But Dylan said to take and do this right here and to do that right there. So it's a 2 by 2. Bring it together and just multiply 1 times 1. Do you see the 1 times 1 right there? So what you have is you think it's rows minus 1 times columns minus 1. And with this, it's a 2 by 2. You can literally just bring it together like this or draw fingers and multiply right there. So 2 by 2 turns into 1 times 1. So correct. When do we do n minus 1? Really good question, Miranda. When do we do n minus 1? And let's review this here. This is a really good time to review. Miranda, keep up those great questions right there. Thank you, Miranda. So there's 3 different times we do the degrees of freedom. When do we do n minus 1? So here we'll bring up a quick review sheet right here. Or actually, jump might be best for this. Okay. So when do we do n minus 1? N minus 1 is for the one sample t. So does everyone see how there's 600 rows right here? So if I want to make one sample t exactly, not anything other, close. It's called the one sample t. The one sample t is n minus 1. So when I do a t-test right here, if I go test the mean, and I say whatever, we'll pretend the value is, sure, this, just close enough so it comes out something. Notice how there are 599 degrees of freedom. So the memorization here is the one sample t is n minus 1. What do we say next? Okay, the one sample t is n minus 1. The two sample t is what? The two sample t is what? Is too complicated. So we won't have you do the two sample t by hand. Two sample t degrees of freedom formula. It's too complicated. That's where you use the TDF calculators. And I can get you a graphic up here in a second. The two sample t is too complicated. So there it is right there. And then the chi-squared is rows minus 1 times columns minus 1. And if you are trying to memorize these, another good thing to do is to go to the formula sheet. We love the formula sheet. And you can see it right down here, the degrees of freedom, rows minus 1 times columns minus 1. The one sample t is n minus 1. And then this says, like, you'd get it from output. Like, we'll show it to you. We're not going to have you calculate it on the test. Once again, everything you can do by hand, everything on the test, you're not going to need applets or things like that. So MuBot's got the applet right there if you want to do it. Yeah, we just give it to you. We just say, and fun fact, like if we were to go here for 10,000 points, does anyone know, and you can cheat and go to the applet too if you want. Does anyone know what the degrees of freedom would be for this? You can cheat and go to it. For 10,000 points, does anyone know what the degrees of freedom would be? This is the 2 sample t degrees of freedom for 10,000 points. Who knows what the degrees of freedom would be? Before I click calculate degrees of freedom. We say it's too complicated, but there's a trick to it. There is a trick. What would the degrees... You can go to the applet and just put in the numbers and get the answer if you want. I know the answer because I know the trick. But the trick only works in rare, certain circumstances. So go to the applet if you want. 398, you are correct. The maximization is total n minus 2. If everything is not equal, it will not be total n minus 2. It is a too complicated formula. It's only when... And great job, a lot of people going to the applet right here. It's only when... Yeah, that's not total n minus 2. It's only when everything's exactly identical, the sample sizes and the standard deviations, you'll get 598. But it maximizes at total n minus 2, which is kind of neat. It's a too complicated formula that maximizes it at its total n minus 2. And good to see you there, Alyssa. So once again, please memorize or look at your formula sheet. The formula sheet has the 1 sample t is n minus 1. The 2 sample t is too complicated. The chi-squared degrees of freedom are rows minus 1 times columns minus 1. Just take fingers, multiply together. You got it. Let's continue on wherever the Kahoot went. Here we go. Classy leopard, majestic iguana, and creative octopus. What is the null for this test? What is the null for the test? Now, here's the thing. What test are we doing? You see it on the screen. You see a mosaic plot. You see this right here. You see that. If you've already answered, tell me the name of the test we are doing, the full name. Or you can just tell me of blank at the end. So what's the full name of the test or just the important parts? Absolutely morbed in. Great job, Giovanna, right there. Chi-squared test for independence. Miranda, amazing work. Miranda, we're going to make Miranda a mod right here. Shout out to W. Miranda right there. Make Miranda a mod. All these right answers. I'm going to assume you're a Stats 1 student. I don't usually mod people during it. Hey, Nick, good to see you there. Chi-squared test of independence. The independence part is super important because we'll see how to do this in just a moment, especially if you're writing this out on the test. So what is the trick when doing the null for the chi-squared test of independence? Okay, good. I didn't block the null. I'm not blocking the right answer. What is the trick when doing the chi-squared test of independence? Like, what is the trick to it? I'll probably have some. It's gonna, it gets busy. I gotta talk to the graders. I think I'll do some Roshni or Riley. Yeah, I think so, Roshni. Yeah. But Jake's got it. The null assumes independence because it's a chi-squared test of independence. We just say x is independent of y. X is not independent of y. So all you do right here is you bring back up the media. And then between the words, you just write, all you do is you just write the word independent. Yay! Aw, thank you. You know what? Kayla, I want everyone to give... Kayla, this means a lot to me. We already had another student drop by, and Rotowave got us a 50,000 point bomb. So, Kayla right there. Everyone give some W's for Kayla. I do remember, I think I remember a picture from the chat. Kayla, thank you so much. I want people to... Even another guy tell me, he's like, yeah, sometimes I tune your streams. And that means a lot to me. Yeah, we've been dropping some crazy points, Nick, right here. But really, thank you. I'm glad people can still enjoy this class and get something out of it. I want this class to be positivity. I know stats isn't the most fun thing sometimes. I know you're like, man, I don't want to do stats anymore. But I like it. That's why I do it. And it means a lot to me that former students, current students enjoy it. I've literally said this, that I have 2 goals in this class. 1 is that you learn stats, and 2 is that you You're just better. Rotowave's still here. 2 is that you just have a better life. I want my class to be part of like the happy parts of your life. I hope we've achieved that. So 2 goals. And truthfully, I'd rather achieve that this class makes you just a happier person, because that's kind of the point of education, is give you a better life. So we're gonna just want this to be a shiny part of life. Okay. Classy leopard, majestic iguana, creative octopus. Let's go. What is the alternative? You should get this pretty easy, because if the null is independent, you should know the alternative. Now, did I throw any tricks in here? I'm trying to remember. I did. I think there's multiple right answers. So what does independent mean? We actually reject the null right here. I might be blocking right answers. If you say gender and breaking a bone are independent, what does it mean about somebody's gender? If you say gender and breaking a bone are independent, what does it mean?
It doesn't matter.
If you say gender and breaking a bone are not independent, what does it mean?
It matters.
Get to some studying, Rotowave. Well, thank you, Rotowave, for swinging by. All the positive energy to you right there. So the null hypothesis means whether your gender, whatever your gender, it doesn't matter. Rock knows.
It doesn't matter.
Breaking a bone, people aren't going to be more likely. Do you think being a cheerleader is associated with injuries? Sorry, it's actually one of the most, shouts to cheerleaders, like the Flyers and stuff. Do you think being a cheerleader is associated with injury? Shouts to them, because I could never do that. I'd be too afraid. They said, Brown, we're going to toss you 10 feet in the air. I said, nope. I'm not doing that. We'll catch you. Yeah, it's really amazing to see, like, especially like when they do like spins and flips. That must be so cool. I'm never doing that. I mean, it's just because I'm too big for that. So the null hypothesis would be that cheerleading is not associated with injury. The alternative hypothesis would be cheerleading is associated with injuries. And once again, shouts to them. I was going to use football, but cheerleading or dance and cheerleading, I guess dance is a little different, and you're not going to throw me in and dance. Well, that's right. So the null means you wouldn't expect any differences. So when you think about the alternative, it means there's something about the 2. It doesn't say that they prove or cause. Remember, if you see prove or cause in any question on the test and it's a true false, what are you probably going to write? With 99%, and I'm almost teaching the test right here. If you see prove or cause, what are you almost going to say? False right there. You're going to be like, we don't prove things here. We don't cause things here. It doesn't show cause and effect. We don't prove things. We don't accept things here. We don't approve. We don't cause. We're always morbed in. Let's do this. Leaderboard Tom. Great job. Majestic Iguana. Remember, $20 Amazon or Starbucks. Email me if you win and let me know which one you want. Correlation does not mean causation. Dawn, great job right there. Find the missing value. Can you do it? People are morbed in. So what value are you trying to find? You're trying to find an expected cell count. We went over this formula earlier. There's quick ways to get it. You can actually get this answer in moments if you cheat. Not really cheat, but it's pretty easy if you do the Sudoku trick for it. We'll show both ways to solve for an expected count right here. Does anyone want to put the formula in the chat for people who are stuck? Notice how it says expected right there. So that means you're solving for an expected. There are questions that blank things out like this on the test and say, well, can you find that value? So we'll show how to get it in just a moment. But you should know you're trying to find the expected cell count. Nice job, Ellie. 5,000 points. Row total times column total over grand total. Maybe I'll start solving right here because this is a bit of long Kahoot, but let's start solving it. This is for the chi-squared test of independence. And we see right here. So what you do, as great job, Douglas, Ellie, and everybody, row total times column total over grand total. You circle the row total, you circle the column total, you divide. Really? You divide by the grand total. And so the row total is that. It makes like a crosshair in on it when you think about it. Like if you go across, and I'll erase it once I do it. Well, I should have done the other one. It's going to be the blue answer. Because Sudoku trick. I wonder if anyone did the Sudoku trick. If you go right here and do this, it crosshairs in on it. Did anyone do the Sudoku trick, though? The answer to this is going to be 261.895. And why? Who can tell me why this trick works if you want to do it that way, too? Nice job, Nick, right there. I like that. Probably so. What you can just add these up. You could subtract from it. Like you can Jake's got it right there. And that's once again, that's not the official way to solve it because you don't usually have the answers to get it. But when we test you, you can mathematically subtract from this because the expecteds have to equal this. So this is how many people born in Tennessee you would expect to be female. So that's got that right there. Great job. A lot of people got this. Really good work. I'm happy. That's pretty good answers. So Rototom's column over grand total, and you get the formula sheet. Leaderboard, Majestic Iguana, Classy Leopard. I'm rooting for Classy Leopard and Majestic Elephant. And you, Captain Boa, even though you got an eye patch on. Like it. Find the missing value. I'll disappear again. You should have the totals. We don't usually remove those, Riley. We could, yeah, you'd have to have the totals to solve for this. Mathematically. Now you're trying to find a cell chi-squared. Does anyone want to put the formula in the chat? Do it once you've solved it. There's the abbreviations I want you to use. It's easier to use those. Remember, it is quantity on the top. It's not just, I'll say it in a moment, but I want you to try to remember it, and it is on the formula sheet. The more you look at the formula sheet and know how to use it, the better you should do on the test. I can't promise, but I can hope. Who knows it? This is a cell chi-squared. A cell chi-squared. I'm going to blank the screen for 2 seconds here and take a screenshot. A cell chi-squared. Okay, let's look at it again. A cell chi-squared. We know it's a cell chi-squared, because that's what it is. But it's right here on the third option, the cell chi-squared. Observed minus expected squared over expected. Observed minus expected squared. Quantity. Great job right there. Over expected. Great job, Ellie, too. And one error I do see when people solve this is, don't worry, I think everyone's doing it great, is they don't do the parentheses on the top. It's a squaring of the difference. And it's not just the E. Don't worry, because I'll say observed minus expected squared, and then make sure it's of the quantity. So you just have to plug in the numbers of the observed is the count. You want to grab this number right there. The expected is going to be the expected, which it literally is. And you grab these. This is going to be 4 squared 16 over that. So you could rough estimate it, but it's going to be that number there. So just plug in your numbers. I'll write them down for you to see. 128 minus 132. I'm just rough estimating it. Over 132, so that is 16 over 132. Would get us close enough if we carry decimals on the test, but 16 divided by 132. And there it is right there. Once again, if you solve it more exactly, you'll get the exact answer. Great work. Good practice. Next, leaderboard. Majestic Iguana, Creative Octopus, Majestic Mystery Elephant. Great job. Nice work on the leaderboard. What are the degrees of freedom for the one stable t-test? I know you got this. You got this. Good review right here. So thank you everyone asking, like, wait, how do we find degrees of freedom again? The degrees of freedom for the one sample t, what's the formula? The degrees of freedom for the one sample t is what? When we're just testing the mean. I'm going to ask a follow-up question that's a little bit harder. It's n minus 1. Great work. Then I'm going to ask a harder question right here. So it's nice job. A lot of people got that. What is, and I hate the decimals on this, but we're going to do it. We're doing it. We're here.
It doesn't matter.
We're here. I totally memorized where the rock is at. I need to hit other buttons.
Wow.
All right, we'll do it. It's another one time. Okay. What is the margin of error on this interval? There's a lot of ways to find it. Who can solve the margin of error for 5,000 points on this interval? I'm going to start doing some drawings to help illustrate what it is. I can tell what it is to a few decimals. Yeah, I've got it to the 4th decimal. Let's see if you can find it. So I'm going to illustrate. It's Catherine on fire. Yep, Catherine's right. And so if you notice the numbers I'm highlighting right here, the upper is the top of the interval. And there's a lot of ways to get this mathematically, but let's just round to, let's say, 3 decimals right there. This is 3.833 because that's y bar, which is the center of interval. Then the margin of error, you go plus the margin of error minus the margin of error. And so we have to go up to, or down to, 3.817, and we have to go up to 3.849. And so you can literally just subtract the numbers. Does everyone yes, Jake, on fire, a lot of decimals right there. I like it. So you can take 3.833 and subtract either number, 3.817. There is a classic way of doing it, though. The classic way is going to be upper minus lower. And then you have to take this distance and what? Because this distance is going to calculate to this. This is what this calculates to. You have to take that distance and do what to it? Because this is a margin of error. So visually, you're taking the full difference and divide by 2. Does that make sense? Like, hopefully some of these visualizations help right here. So if you just plug in the formula upper minus lower, so this is the upper minus the lower, divide by 2. You just take these numbers, that's the upper, that's the lower, and divide by 2, half the length of the interval. So that's another classic solve for it. So hopefully visualizing this out for you can help show it. If you really want all the decimals, which I think Jake did, 4192 minus 3 point, sure, I got it, good. 81736, that's the distance, half the distance is that, and that's exactly what Jake did for another 5,000 points. So make sure to know how to find things like that. Excellent work. Next question. Majestic Iguana, Creative Octopus, Classy Leopard, Rocky Shark, great to see here, and Mystery Elephant. What is the missing p-value? This one trips up a lot of people. What is the missing p-value? Now, p-values have relationships. P-values have relationships. There are how many alternatives? There are how many alternatives? How many alternatives are there? How many alternatives are there? 3. There is the does not equals. I'll do it in a different color. There's the does not equals. There's the greater than and the less than. When doing alternatives, they have the following relationship. If you are doing a greater than alternative, you shade to the right. If you're doing the less than alternative, you shade to the left. If you are doing the does not equals alternative, you shade both sides. So you'd shade just as extreme on the other side. You'd shade both sides. So when we think about these values, we're given a few of these, and I should have put them in order. The does not equals alternative has a p-value of 0.0041. The greater than alternative, which is here because we're shading to the right, because notice how it points to the right, is 0.9979. So how can you get this less than alternative? How can you get the less than? There's 2 ways to get the less than. How can we get this less than? Notice that this is in the same spot for all these curves. It's in the same spot. So how can we get the less than? What is the trick to get the less than? How do we get the less than? Exactly. Catherine's got both. Gee. Wow. Impressed. Very impressed. 0.0021, because these have to add up to 1. Or you can just take half of this because it's only 1/2 of the total on the outside. Does that make sense right there? It's just half. You can think because this has been doubled. The does not equals is double the smaller. The less than and the greater than add up to 1. Pretty good work. Some people picked this one, but pretty good work. So it's in this round to 0.0021. So make sure to know the relationships. Let's test your knowledge with another question similar. Majestic Iguana, Creative Octopus, Classy Leopard, Magic Wombat. Shouts to Wombat right here. Women in Business Analytics at the University of Tennessee. Rocky Shark. And a lot of them graduated. I'm happy but sad still. Next question. Find the missing p-value. Very similar. This will test your knowledge. I like to do repeat questions. If you know, you know. We have the less than test. We have the greater than test. We are missing the p-value for the what test. The what test. There's a less than test, a greater than test, and a what test, which is also some of the basic questions on what are the 3 alternatives. And there's a less than test, there's a greater than test, and there's a There's a less than test, there's a greater than test, and then there's a dot test. The does not equals, Catherine rates work. So the less than test, the greater than test, the does not equals test. The does not equals test, write this down. Its p-value is what of the what. the does not equals test, if you look at the other p-values, these two have to add to 1 because you're just shading below that and above it. So the does not equals test is always what the whatest. The answer is, if you know it, yeah. Does not equals test is always what the what or p-value. 2 times the smallest. Nice. 2 times the smallest. So we just take the smallest and we do it right there. Great work. Good review. And just remember, double the smallest is the does not equals test. Who picks the sign of the alternative? Let's do a vote in the chat. Don't answer in the chat, though. Like, you'll click a button. Is it the data or the researcher? Who picks the sign of the alternative? Is it, click the button in the chat if you remember. Is it the data or the researcher who picks the sign of the alternative? Majestic Iguana, Creative Octopus, Classy Leopard, Magic Wombat, and Focused Llama on the leaderboard. We've had some mix up here on the bottom, but Lovely Zebra. Hopefully you get to the top. Next question, what is the missing T ratio? Let's see if you can do it. Okay. And the answer to the in-chat question was, it is the researcher's question picks the sign of the alternative. It's always the researcher. And if you think about the process of it, the researcher comes up with a question and then they collect data. So the data is only acquired after the researcher figures out what they want to analyze. You wouldn't collect data and then come up with a question, because that's kind of what we call p-hacking. You're then fitting your ideas to what the data shows you, not coming up with your idea and then seeing if there's evidence for your idea, which is what we do. Okay, so how in the world do we find this missing T ratio? It's pretty quick. The formula seems complicated, but we'll see in a second. Every test is a whatized. Every test, that's not the right T ratio, good. Every test is a whatized. Every test we do is a good note to have, and it basically is like for all statistics. Every test is a whatized. A different standardized, exactly. Different standardized. So look, we have a difference. The difference is y bar 1 minus y bar 2. Y bar male minus y bar female. That's what the difference is. And then the standard error of the difference is what we standardize by. And that is equal to the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And we just what these values. You just take these values and what them. You just take these values right here, because that's the difference, and you just divide them. Exactly, that's all you do. So you just take these values and divide them. That's the T ratio. So notice it's negative 2.3 over, that is the T ratio, so put it right here. And we go negative, or can't do it yet, 2.3016, negative, divide by 0.02318. And there it is right there. It's basically, there it is. That's the number. There's another word for the T ratio, right? It's called the t-test statistic. This right here is the formula on the formula sheet. The T ratio, Jump calls it that. It is the test statistic T. I'm trying to find, sorry, as I blink through a few screens. Here we go. This equation is this equation right here. We often hypothesize that the difference is 0. This equation I'm hovering over right here is the equation I just wrote out there. The y bar 1 minus y bar 2 minus 0, because 0 is the hypothesized difference, over the standard error, which the standard error is s sub 1 squared over n sub 1 plus s sub 2 over n sub 2. I usually just write out that right there. So the difference divided by the standard error is going to be the T ratio, which is the T statistic when doing the test. Good questions right there. Riley and everybody, keep asking those questions. Thank you. So here we go. Leaderboard Tom, Majestic Iguana, Creative Octopus, Classy Leopard, Magic Wombat, and Mystery Elephant. Next question. What is the missing value of the difference? So what would this mean? Think it's a T ratio. That means your difference has to be what, though? If the T ratio is negative, your difference has to be what? Which doesn't really help us. So if the T ratio is negative, because you're dividing these numbers, standard error can't be negative. It has to be negative. But also it means that the difference is about 10 times larger. That kind of answers it. Now, if the difference is negative, like, let's just pretend this one's the answer. We'll just pretend that's the answer. Like, we'll just Pretend that the answer. So if that is the difference, and this is in GPAs, what does that difference mean? In our sample what? So this is GPAs we're measuring, male, female. The difference is negative. What does that mean? So what does that mean if that is the difference? If that is the difference right there, what does it mean that the difference is negative and we're analyzing GPAs? I'm sorry, guys. I did not help out with this data. But you get what I'm saying. Since the difference is negative, in our sample, we observed what? Since the difference is negative, correct. Since the difference is negative, in our sample, we observed that the female GPA was higher by 0.23016 than the male GPA in our sample. Now, here's the thing. I am 95% confident that the true difference between male and female GPAs is that the average female has between a 0.18467 GPA higher than to 0.27564 GPA higher than males. I might tidy up that a little bit, but this is the interval to estimate the true difference. And notice what is not contained in this interval. What value that I'm about to write is not contained in this interval, and this leads to what we're doing. What value is not contained in that interval? What value is not contained? Which is up there with the null. What value is not contained in that interval? 0. So you'd reject that there's no difference. You could also have evidence that the female GPA is higher than the male GPA because the interval is completely negative. There's like a beef hot dog question that goes over that. But we could definitely, I'm running right here the does not equals alternative, and I'm seeing if there is a difference. That's what I researcher questioned, and that is horrible. My researcher question was, is there a difference? And I do have evidence of a difference because I ran the does not equals alternative. Also, 0 is not contained in the interval, and this would come to the same conclusion where I'm running at alpha equals 0.05 because I ran a 95% confidence interval. Using the 95% confidence interval, we'll come to the same conclusion as a what-tailed test with what alpha. Using a 95% confidence interval, we'll come to the same conclusion. If you run a 95% confidence interval, it'll come to the same conclusion as a what test with what alpha. The answer's kind of on the screen. It'll come to the same theoretical conclusions like when you run it. So doing a 95% confidence interval will come to the same conclusion. Nice job right there. Running a 95% confidence interval will come to the same conclusion as a two-tailed test. Do you see how it's like the inside-outside? And so it'll come to the same conclusion as a two-tailed test with 0.05 alpha. Now we could change this. It would come to the, if we ran a 90% confidence interval, it would come to the same conclusion as a what? Two-tailed test with what? If you ran a 90% confidence interval, it would come to the same conclusion, like whether you reject or don't reject the value based on if it's in the interval or out of the interval. It would come to the same conclusion as a two-tailed test with what alpha? Running a 90% confidence interval would come to the same conclusion, and just think it's inside-outside. It's complements. Boom, 0.1. Nice job. Nice job, Douglas and Riley and Catherine, and great job, Brando, too. Okay, lots of review. Here we go. Next question. Or leaderboard first. Nice job, Silver Griffin. You get the shout out. What is the null hypothesis for this test? What is the null? Well, can anyone name the test we are doing? It's really easy if you know how to write nulls. Great job, Nick. Can anyone name the test we are doing? What kind of test are we doing? What? What kind of test are we doing? The two sample T. We are comparing something between male and females, maybe GPA again, and there's still a difference. We still reject that there is no difference. We have evidence of a difference, whatever we're comparing. And so the null hypothesis, always remember, I hate to give this one away. I shouldn't have put 90 seconds on it. Say it with me. The null has the what? The null has the what? Whenever you write the null has the what? Nice and easy. Has the equal sign. The alternative has the greater than, less than, or does not equal. Those are possible alternatives based on the researcher's question. So whatever the researcher wants to analyze, is it true that males have lower average than female on whatever this is? Is there a difference? Does not equals alternative. Are males on average higher than females? That could be tested right there. The degrees of freedom comes from the too complicated formula. What is the math? Can anyone write the math? You can abbreviate to 3 decimals. How do you get this T ratio? Review question. How do you get that T ratio right there? How do you get that T ratio? Show me the math real quick for that T ratio. And great job on this one. People know the null has the equal sign. How do you get the math for the T ratio? How do you get the math for the T? I'm changing it, but just show me the math for it. Changing it to this. What would have been... Yeah, and then put the math... Catherine, great job. I think you know it. It's going to be just divide these two numbers, which I changed it. What would be the p-value you would estimate? What p-value would you estimate if this was the new T ratio? Let's go one last 50,000 points. And then you'll be like, I don't need t-tables anymore. I don't need t-applets, especially if it's really large. One last 50,000 points. Crazy morbid in points. What would it be? Close, Catherine. Not quite 0, though. Good guess. If I draw it out, you'll see it and know it. I guess I'll do it. Really? I hate it when it moves, though. If I go too far over, it starts to move the screen. So we landed down here at a t equals to -3. We're going to graph the area outside of this, and that's the p-value. But remember, it's the area outside because we're doing the does not equals test. It's the alternative hypothesis is that the mean... Oh, 3,000. I see it. Yeah. Okay, wait. I always have to get the points for that. Yeah, you're right. If it was 3,000, that'd be different. Did I say 3,000? If I did, you'd be 100% correct. It's basically 0 as 0 can be. You are correct. And then here, solve this last one right here. That is correct for 3,000. It would be as 0 could be. So the alternative hypothesis is the does not equal to... The dot was so small. It was hard to see. This is one just as extreme here at a t of 3. And the curve should be closer down, really. Who can get the p-value here? I want someone to tell me what the p-value would be, what you would estimate it to be. What you would estimate the p-value to be. T's are basically Z's. Who can get it? Just take a shot at it. Don't worry. Catherine, but remember, it's the two-tailed, and Jake got it. Jake and Catherine. I think, Catherine, what I originally drew, you are correct, and Jake, it's because it's the two-tail. I lost my points. I'm going to give you guys the points, though. Does that make sense? I think people are seeing it like, wait, yeah. And if you notice, 0.003, and then, yeah, it's 0.003. Because if you use the empirical rule right here, and which is based on the normal z-scores, but we have so many degrees of freedom that the t is basically like the z. This is 0.997, and then this is 0.015, and this is 0.015. And then if you look, our values are really close to that. Does that make sense? Like, our values on this are actually kind of close to that because we're basically at 3 t-scores, kind of z-scores. Remember, the more degrees of freedom you have, the closer it is to the normal. So you can often be like, oh, my t or z is like 3. Well, p-value is basically 0. Once you get outside of 3, there's so little area that, unless you have ridiculously low degrees of freedom, because then the t is different from the z. It's always different, but it's more different. Who is the dude who invented the t distribution? Really quick, I'll do that on the next question, because I like to do little asides. Majestic Iguana, great job. What is the alternative hypothesis for the two-sided test? You should get this pretty quickly. We're talking about a t-test. And who's the dude? John Statistics. It might be my Uncle John right there, same initials. Who is the other dude? The beer guy. We got William Seeley Gossett. William Seeley Gossett. And he worked at Guinness Beer. William Seeley Gossett. He called it Gossett's t-distribution. It's the does not equals test. That's pretty easy. So you can see William Seeley Gossett. There he is, a little bit younger than me. There he is as an older man. Go to his plaque. There's his plaque at Guinness Beer. It's bigger than that. Is that? No, that's Pearson, I think. That's Gossett? He changed a lot between those times. So there is William Seeley Gossett. Copy image. Bring it over here. Look at that. Chief brewer and statistician at Guinness Beer. And creator of the student tea. He called it student tea. He apparently didn't want any notoriety from it, I guess. But called the student tea test. Student is the pseudonym, and tea is just what it's called. And statistician William Seeley Gossett. I should go check that out. But that is William Seeley Gossett, the creator of the tea test. The two-sided alternative is the does not equals. It's called two-sided. We drew it out a while ago, but you shade both sides of the curve. It's the two-sided test. What are the one-sided tests? The what and the what tests are the one-sided tests. I mean, they're basically on the screen. The what and the what, you can just put the symbols. The one-sided tests that go this way or go this way. What are they called? The one-sided tests. This is the two-sided. So you could do this. You could do that. Those are the one-sided. The greater than or less than. So the greater than the less than are the one-sided. The two-sided, and it's not a two-sample. This right here highlighted in orange means two sample. And this over here is two-sided. Who feels like they understand the difference? I'm going to remove down. This is two-sided. So who gets that when you say two-sample, you're comparing two groups. When you say two-sided, you're talking about the sign of the alternative. So two-sample deals with comparing two groups. Two-sided deals with the sign of the alternative. Because you're saying, let's see if there is a difference. So two-sided is the sign of the alternative. And two-sample deals with comparing two groups. Okay, next question. Majestic Iguana, Aquatic Bear, great job. Here we go. Interpret the difference. You got this. I gave some hints. Okay. First thing to note when looking at the difference, that it is what? First thing to note when looking at the difference is that the difference is what? I tell other educators, like, announce your Kahoot, narrate it, and give hints. Like, basically, I try to have it that by the time the 40 seconds have run out, I give the answer. Notice that the difference is negative. Great job, Tamara. The difference being negative indicates that the second mean is higher by this much in the sample. I didn't write that, but it's true. It's not the truth. This estimates the truth down here. So the difference is higher in the sample for females by 0.04729. The mean for females is this much higher than the mean for men. Well, I think we just did that. It's not proportion because this is a what? Say it with me. It's not proportions because this is a what? It's not proportions because this is a what? Don't know if you selected proportions. It's means, and you're correct, Sophia, right there, because it's a t-test. Since we're doing a t-test right here, we have to be analyzing difference in means or comparing one mean if it's just a one sample t. But great work. Here we go. We're almost done my favorite questions, the story time questions. Next question. Story time. We're here. The null hypothesis is that it is a twig. So you're walking through the woods and you make a type 1 error. What does that mean? Well, in a type 1 error, hold up your finger here. You got 1. The null is true. In a type 1 error, we'll probably do more, Keely. In a type 1 error, the null is true. So if the null is true, what's going on in the world? If the null is true, remember, in a type 1 error, the null is true. If the null is true, what's true about the world? It's this thing right here. And I'll bump into it and I go, it is literally that. That is a fact. When I say the null is true, don't be like, but what if it is? No, the null is true. But you're going to what the null? In a type 1 error, the null is true, but we what it? In a type 1 error, the null is because you're going to make an error here. You're going to do the error. You're going to be like, ah! That literally is the error. In a type 1 error, the null is true, but we reject it. So explain to me conceptually what is happening to you. If you've already answered, explain conceptually when you make a type 1 error when you're walking through the woods. Often called a false positive. You can change. I like to call it a false positive. It's the way I refer to it as. I made a false positive. I saw that twig right there in the woods and I made a false positive. What does that mean? You think it's a snake. And you think it's a snake, but it's a false positive. But what? The alternative is a snake, right? So the false positive is you think it's a snake because you falsely believe. Exactly. You think it's a snake, but it's not. Mm-hmm. So in a type 1 error, the null is true. It's true that it's a twig, but you reject the null. You reject it. You say, no, I saw that thing move. And they're like, your friends are like, dude, it's just a piece of wood. And you're like, I swear I saw it. I swear. False positive, type 1 error. Confirmed. So you think it's a snake, but it's not. You think it's a snake, but it's not. This would be a type 2 error. I made a type 2 error. When I was doing archaeology, there was like all this like snakes under down debris. There was all of this like down debris, and I don't know if I can find an image of how it looked. Oof, man, I'm afraid of. It was like it's like a down tree pile, and there was just all of this like. Oh yeah, it was kind of similar to. I'll show you what was most similar. Ew, yeah, it kind of looked like this. This is what it kind of looked like. Okay, I found something similar. Okay, I think. Okay, here we go. Okay, it was about similar to this. And so we were out doing archaeology. And so here's me. I need to be orange or something. And I literally just start, because I don't know why, but I was like, doo-doo-doo-doo-doo. And then everyone said, Brian, you're making a type 2 error. Don't you know that? And then I hear, and I go, so I thought this whole area was what of snakes. Think about my type 2 error. I thought this whole area was what of snakes. So the null hypothesis is that there's no snakes. Free of snakes, exactly. The null is everything's safe and good to go. So the null is oh my gosh. The alternative is snakes. The null is everything is free of snakes. The alternative is that there's snakes. And so you would need evidence for the alternative. And frankly, I got the evidence. Does everyone understand when did I, full of snakes, does everyone understand when did I get my evidence for the alternative? Think about this. When did I get my evidence for the alternative? I got my evidence for the alternative when what? I got my evidence for the alternative when what? I got my evidence for the alternative when what? When did I get my evidence for the alternative? I got my evidence for the alternative when what? I had evidence for the alternative when what? Thank you, Roshni, right there with the SI. When I heard the snakes, that was evidence. Now, that could have been a type 1 error. My friends could have had like some rattle, some just shh, and I was like, oh, and it caused a type 1 error. I'm pretty sure I rejected the false null. I'm pretty sure I had a pretty powerful test by just walking across it. I got a lot of evidence, and pretty sure that was evidence that was confirming right there. Let's do another story time right here with the next question. Here we go. Story time. What is the type 2 error? The null is that the tree is healthy, and the answer is pretty much on the screen. In a type 2 error, the what is what, and we what it. Say it with me. In a type 2 error, the null is what, and we what it. In a type 2 error, the null is what? In a type 2 error, the null is false, and we fail to reject it. And I think I love it. People were saying earlier that they have people who have like been practicing that with them. In the type 2 error, the null is false, and we fail to reject it. So when you think about what that means, the null is false. So if the null is that the tree is healthy, that's false. Your tree is not healthy. That's a false statement. The tree is not healthy, but when you fail to reject something like I did, I thought, there's no snakes here. So the null is false. There are snakes there. But I didn't reject the null. I still believed there's no snakes. So Brian walked out across that because he didn't reject the null. Now, if I rejected the null, which I should have done, I would have been correct. I would have said, there's probably snakes there. And I would have made the correct decision on that test of not walking across an area with snakes. But when you, in the instance prior, make a type 2 error, which is when you fail to reject the false null, remember the null is false, I assume there's no snakes. So I assumed there's no snakes, and I didn't reject that, but the null is false. There are snakes. Just like in this thing right here, if the tree is healthy as the null, well, that's false. The tree is not healthy. What would be a type 1 error? Can you explain to me a type 1 error? In a type 1 error, the null is true, but we reject it. What would be the type 1 error in context right here? What is the type 1 error in context? What is the type 1 error in context? What is the type 1 error in context? Boom, Douglas on fire right there. Exactly. The type 1 error would be the null is true. This one doesn't say type 2. It says type 2, but if a type 1 occurred, it would be that the null is true, the tree is healthy, but we chop it down. I'm sure people make type 1 errors all the time. They're like, that tree doesn't look good. Let's chop it down. Let's be safe. Which error is worse? It's context dependent. Maybe you don't want to chop down every tree, but you might err on some type 1 errors if trees are like leaning weird. You might say, let's get some type 1 errors. Make sure we don't get any trees falling on the house. Classy leopard, majestic iguana, creative octopus. Here we go. When doing a 2-sample T, the variables will be what? A lot of people get this wrong. When do we use 2 categorical variables? When do we use 2 categorical variables? When do we use 2 categorical variables? 2 categorical variables is the count data condition. Chi-squared test of independence. Chi-squared. Yep, that's chi-squared. We'd never use identifiers. I mean, like, they identify. That's the point of them. The point of identifiers is to identify.
Wow.
Right there. Well, that wasn't another one. I see where I should be at. So people are probably between the 2 answers on the screen on the bottom. Here's the issue. What is the point of a 2-sample t-test? To do what? What is the point? Don't worry if you get this wrong, but what's the point of a 2-sample t-test? What is the point of a 2-sample t-test? Oh, we did pretty good. What is the point of a 2-sample t-test? What is the point of it? Compare the means of 2 groups. Now, if you have 2 quantitative variables, what are you doing? If you have 2 quantitative variables, what are you doing? If you have 2 quantitative variables, what are you doing? If you have 2 quantitative variables like year and price, what are you doing? If you have 2 quantitative variables, what are you doing? QQ, straight enough, no outliers, plot doesn't thicken. What are you doing? If you have 2 quantitative variables, what are you doing? There's other things you can do too with 2 quantitative variables. What are you doing? Regression. Or you can do correlation. I know that's identifier, but we'll just throw it in here because it's alias does that. So you can do correlation, all these different things here, regression. But look here, the 2-sample t-test compares the means of 2 groups. Very important right there. Next leaderboard, majestic iguana, creative octopus, classy leopard. Great job, helpful unicorn. Next question. When working with statistical power, what do we have the most control over? So statistical power is known as 1 minus beta. Beta is the probability of a type 2 error. Alpha is the probability of a type 1 error. So beta is a type 2 error. Alpha is a type 1 error. So when we do the statistical power, there's 3 things that impact it. And let's draw that out. How do we draw it out? Okay. If you are doing a test, you do not want to make a type 2 error. Beta is your type 2 error. What is something that is inversely related to type 2 error? What is something that is inversely related to type 2 error? That's what we're about to do right here. Sample size. And actually, I should do this. If sample size goes up, your type 2 error goes down. So that's sample size. What's another thing? What's another thing inversely related? And sample size is what we have the most control over. Effect size. And we'll talk about that in a second. And what's the last thing? Effect size. And also alpha. Alpha is your type 1 error rate. And there are 2 things, I should have said that. Type 1 error rate we can also control, but in most instances is 0.05 unless otherwise stated. So the thing with this is, if you want to do better tests, usually you get a what? If you want to do a better test, usually you would do what? And if you increase your sample size or any of these, you will decrease type 2, take larger samples, which are hard to get a lot of times. And that'll decrease or increase power. So this is the name of the term associated with like that sample size. This is effect size. This is alpha, which is type 1 error. Sample size is that. This is beta, type 2, and power is 1 minus beta. So those things right there, like sample size is lowercase n. So the way this works is, imagine there is, like, let's say we're trying to figure out if somebody is sick. When would we be able to better detect, which is power, which is the ability to correctly reject the false null? When would we be better able to detect someone is sick? Power, ability to correctly reject the false null, which means the null is that they're healthy. So the null is healthy. The alternative is sick. So would it be if we took a sample size, really, of, let's say, 1 vial and tested it, or 5 vials? When would it be better, easier to detect someone is sick? With 1 vial or 5 vials? When would it be a bit easier to detect? 1 vial or 5 vials, which is larger sample size? 5 vials. And think about that. Then we would be less make a mistake, because a type 2 error is when we fail to reject the false null. They're actually sick, but we say they're healthy. So we'd make less type 2 errors, known as a false negative. Now, effect size would be, what if they just have a little cough? Or what if the person is like laying down and can't get up, and they're passed out and they have a fever? This is what effect size is. They have a fever, they're passed out, or they just have a cough. The effect size is known as the true difference between the null and what we observe, or what there is, the truth and the null, excuse me. The effect size is known as the true difference between what is true and the null. So if the null is that they're healthy and they really are just a tiny bit sick, that's a small effect. If the null is that they're healthy and they're super duper sick, that's a big effect, which is easier to see. We'd be less likely to make a type 2 error and not find the sickness. The test is going to have more power. It's going to be easier to detect, the ability to correctly reject the false null. Now, the easiest way to find all the sick people is to manipulate alpha, which is a bad idea. What's going to happen right here if we set our alpha all the way to 1.00? Well, we can't make a type 2 error. Why? What's going to happen right here, which this is not a good idea. This is bad statistics. What is going to happen here if we set our alpha all the way to 1.00? And think about type 1 errors. In type 1 error, the null is true. Someone's healthy, but we reject the null. So then we can't make type 2 errors, right? What's going on? It's very easy to do an alpha of 1. Or do an alpha of 2, which you can't really do, but you would. You can't do an alpha of 2. Alpha can only go to 1, really, theoretically. But what am I implying with an alpha of 1? What am I implying? And these are the things that influence the power right here. We'll always reject the null. So you just say everybody's sick. And then what have you done? You've basically said a lot of healthy people are sick. So if you increase the alpha really high, you reject the null all the time, you don't really mess with alpha. This would just lead to tons of type 1 errors. And if you make type 1 errors, you can't make type 2 errors. Like, the more type 1 errors you make, the less type 2 errors you make. They are not complements of each other. They are inversely related. They're just, if alpha goes up, beta goes down. If effect size goes up, beta goes down. You don't control effect size because you don't control how sick people are. You can control how many vials of blood you take. You can control when you reject the null, but that's messing with stats. 0.05 alpha unless otherwise stated. So keep your alpha at 0.05. That's proper statistical techniques. Let's continue on right here. Last few questions. Great job, Creative Octopus. Calculate degrees of freedom for freshman, sophomore, junior, senior, and owning a bunny. Yes or no? This is a what by what? So it has how many degrees of freedom? I put way too long for these questions. One more question after this, and really good work, everybody. This is a what? It's a 4x2. That's the answer. Can you see it? That's all you got to do. Yeah, Douglas did it. And we had Daryl make it up. So, and people are getting it. Isn't, when you know how to do it, isn't it just like, psst, you say, Brian, 4, 2, and then we came up with this new thing this semester. You just bring it in like that. So huge shout out. I think it was Dylan, as we said, made that up. He was like, Brian, it's just easier. Just do that. And then it's 1 times 3. So once again, rows -1 times columns -1. I used to do, I don't even know what I'm doing. But it's easier when you just bring your fingers in like that, especially when you don't have that large of a matrix to do, when you're not doing like a 10 by 9. If you did 10 by 9, what's the formula for the degrees of freedom? If it was like 10 options and 9 options. Because if you know it, you just like, you don't even have to solve it. You can give me the answer. But if it was a 10 by 9, there's like 10 restaurants with 9 dishes you can get at all the restaurants. We want to see if there's an association between, or if the restaurant is independent of how good the dish is, or how many people order that dish would be. If the restaurant is independent of how many times that dish is ordered, boom, Tamara's got it. Yeah, it's just that, Tamara, right? You just drop each one, multiply. So, and it is on the formula sheet. There we go. Last leaderboard before the big one. Creative Octopus, Majestic Iguana, Classy Leopard, Civil Griffin, and Magic Wombat. Here we go with the last question. How could someone make this test more powerful? Now, one of these is ridiculous. But remember, there are 3 things that impact power. So power is the ability to correctly reject the false null. Power is the ability to correctly reject the false null. You have no control over effect size. And a bigger effect size would be more powerful. But you don't control it. You don't control how 6-1 is. At least I don't think you do. You shouldn't. So the bigger the effect, the easier it is to detect and correctly reject the false null. Because power is the ability to correctly reject the false null. 1 minus beta is power. You don't directly manipulate that. That's kind of true. When would power be higher? When 1 minus beta is higher, but you don't directly manipulate 1 minus beta. It's manipulated by the 3 things way over here. You don't directly manipulate beta. The 3 things that impact beta are going to be sample size, effect size, and type 1 error rate. Type 1 error rate being your alpha rate. If you decrease alpha, then you would increase beta. It would go the other way. If this decreased, this would increase, and this would decrease. So power is directly related to increasing any of these. And of course, the number one way to increase power is going to be to increase the sample size. So that is the best way to do it. Usually we don't have to worry about the 10% condition where we want to take less than 10% of the population of interest. Good to see you there, Lydia right there. If I mispronounced anyone's names, please let me know. I'm very bad at reading. But amazing work right here. Congratulations to everybody and great semester. Really appreciate it. Does anyone want to drop the degrees of freedom for this with our last 20 seconds? This is a 1 sample t-test. What are the degrees of freedom? Super easy if you know it. So good work. If you want to drop the degrees of freedom, and we'll look at the leaderboard here. We'll look at our island. 769, you got it right there, because the N-1 1 sample t-test. We're maybe testing the true GPA of all students. Great job, Dawn and Tamara and Reese and Roshni. Let's check out the leaderboard. Here we go. We've got in 3rd place, we've got Classy Leopard. In 2nd place, we've got Creative Octopus. And in 1st place, make sure to email me, all 3 of you, for your Starbucks or Amazon gift card, Magic, Majestic Iguana, I think it was. Now remember, when you email me, say, hey, Brian, I'd like a Starbucks gift card, $20 Starbucks gift card, or $20 Amazon. Make sure to email me and say which one you want. And let's look at our rewards. Our island's gotten so huge. Awesome. Colin, one last. We've had 3 people. Colin, you're the 3rd. Dropping us another 50K right here. I tell people we have people swing by, and that's some huge points for them. So if you've stayed morbed in the whole time, you've been getting these points right here. We've got our leaderboard right here. So Colin, thank you so much. Happy to see you in the chat as always. Yes. Well, that's all right, Catherine. That's fine. Do you wanna pass it to 4th place, Catherine? If your call, it's totally fine if you've won. You earned it. You won. If you've won, you've won. Do you want to pass it to 4th, though? And if 4th is here, then we could say that. If you want to pass it to 4th, say, give it to 4th. That's very kind of you, Catherine. So, Pixie Dust from Disney. Yes, I love it. And I want to say, yes, 4th place. 4th place if you've won. And you know what, Catherine? Out of the spirit of what you've done right there, I'm also going to give to 5th place also. So, Catherine, I appreciate that. I want people to just have a good end of the semester. If you're hearing this now and you're in 4th or 5th, if you chilled out for the last few moments and you hear this, because I don't know if 4th is still around. If you're in 4th or 5th, email me and let me know. But out of the spirit of Catherine being so given right there, we're gonna double that gift. It's like I will double all. First, it's like, can you double it for the remaining one? I'm like, no. But I appreciate it. And Kayla, great to see you. Thank you for swinging by, Kayla. Appreciate former students being here. We keep getting all our Kahoot achievements. You're welcome, Ellie. Shout outs, Ellie, right there. Let's throw another 5,000 points. W. Catherine right there for 4th and 5th. So I'm glad 4th, or we got 5th getting it right there. But huge shout outs, really good practice. We will be reviewing more later. And thank you, everybody. I'm going to go see me around campus right here. Catch me outside. How about that? I'll be outside. Thank you, everybody. Arashni, you're welcome. Dawn right there. I'm glad the videos helped. Make sure to check out the review videos. Holden, awesome. Thank you, everybody. I'll go to the main screen. They'll end here in a moment. I'm very thankful for everything. I'm thankful for just that I get to teach here and do these things. I mean, who else gets to like have a class on YouTube, you know? Did anyone of you ever think that you would be like in a YouTube class and that it would work? That it would actually like work? Like, you'd never think, I don't know. If you asked me like 6 years ago, because I've been doing this YouTube class now for, actually, this is year 6. I did not, Nick, right there. Thank you, Nick. We started this class in fall, and I said I was going to show this, so I'll show this at the end. Last class, I said I'd show the beginnings of it, so if you want, love it. Thank you so much, Anna. I'll show this at the very end right here. I'm going to my YouTube channel and going to the live streams from forever ago. I can actually sort by our first live streams, and the very first review session ever on YouTube. This is from a decade ago. There's me 1 year ago. Or 10 years, what did I say 1 year ago? It's literally over a decade ago. Oh, you can't see it. There's me a decade ago. Sometimes my hair is a little bit longer. Oh, I love that Express t-shirt. It's gone. So this is a decade ago, the first stream we did. First, talking with my hands still talking with my hands. So 1 decade ago, we got the stuff on the screen going over, and students thought it was so amazing. There's 1 decade ago. What's up, Brian from the past? Just look at the screen right there. No, little young Brian. Just staring at the screen being like, because the online chat was there. So, and then what we did was, I'll bring up the next thing. What we did is we started doing the Kahoots. The very first Kahoot, and this might be the one. I'm actually talking to my wife on the very first Kahoot. We did a Kahoot 7 years ago. So this is 7 years ago Kahoot. 7 years ago. Gosh, this is how Kahoot looked 7 years ago. 7 years ago. And I had better green. I actually borrowed a green screen from the library to do this. So this is 7 years ago, our first Kahoot. Kahoot looks a little bit different. And we don't got cool leaderboards. It did this at the end. It just showed it right there. There's OBS. Because I don't have a multi-screen at this point. I'm not using my multi-4-screen setup at this point. So that's our first Kahoot. And then where things started to change, and I have to say a huge thank you to Mark Collins and all them, because what happened is we got a lot of like money input into this. This is 6 years ago now. This is where we started to get, the university started to say, hey, we like what you're doing. So this is 6 years ago. We still have the same title screen. And this is our very first, we have those little intro screens. This is the very first intro and I still have it. I think I could pull it up still. This is the very first intro. Thank you, Dwight. Dwight Campbell made this first intro for us. And it's like, and then I'm like, okay, this is how we'll work it. This is what we'll do. I'm like, and I was standing back then, different screen and everything. And I have I've got the big Stream Deck now. Can't get it on camera. It's a big it's the Stream Deck XL now. I can actually show it if I click the buttons. Yeah, so I've got a Stream Deck XL now. I'll bring that on the screen down here. So there's the Stream Deck XL, which I use now. You're welcome, Brando. And huge thank you to Mark Collin. There's Dwight Campbell. So Dwight working away right there, working his magic. Is that Jason Greenway in the background? I thought I saw Jason. There's Jason Greenway. Oh, man. This is us trying to figure out how to do everything. Gosh. Jason Still, he teaches in marketing now. Shouts to Jason. And then we see Mark Collins, who gave me so much help. I'm like explaining everything to him, and I'm like, okay, so this is how we'll do this, and this is how we'll do this, and this is this. And we were going to have like the agenda on the right, but it was a lot of work and just didn't work out. Like, here's what they'll be learning as I go through what's on the thing. I thought there was two of me. I saw that. And I was like, why is there another Brian right there? So we were just like trying to get this working and like trying to get something going. And it's kind of fun for me to walk down this memory lane too. Is anyone still here as I go down memory lane? Is anyone still hearing all this? Stacy, yeah. Oh, thank you. Thank you, Stacy. She's awesome. Stacy is an amazing teacher with so much energy and so much creativity and working on so much with us, getting things ready, especially improving Stats 1. So thank you, Stacy, and everybody. So here's kind of, we've got things a little bit better right now. I still have that t-shirt. And I was like, okay, I'm going to be standing. There's Jason over there working on it. And man, it's like, I haven't seen this old setup in a while. It's just, we were going to try to do like more like, it just became a lot to like make all the graphics and stuff. And it just evolved over time into what it is. Like this was the first iteration. If you see right here, test stream 5 years ago, almost 6 years ago now. So test stream 6 years ago where we did that. And I'm just trying to show you more of the evolution of it. Here is chapter 2. Okay, so here is literally how it looked for students in fall 2019. So this is fall 2019. Students were in the class. And what do you think? Does it look better now? See, I would be in front of the screen like that in the corner. And I was standing the whole time. And I'd be in the corner, and you had a lot of stuff on the screen. And we actually changed this every class. We'd change what the chapter was in the corner, which became a lot of work. It was a lot of like, okay, we got to load in these graphics, got to load in these graphics. And so thank you to Jason. He kept making the new graphics. I was like, okay, I need the new graphic for today. And we'd like Pearson over there in the corner for statistics. But students really liked it. And then I'd have to move myself around. I wasn't as quick with everything. But it was what we didn't have MuBot back then. Yeah, Dawn, thank you. We didn't have MuBot hover over. So it was pretty interesting. It was pretty crazy. It was totally like very, very different back then. And we'll see one more. It's fun going down memory lane of this. Just seeing even I see, like how much things have changed. Like what really changed everything was when I went to Texas. And then I pretty much had to change what I was doing even more and upgrade it. And there's test stream 2. Oh, well, that's not the COVID one. When COVID hit, that's when exam review 2. I wonder if this one, this got almost 5,000 views. What was I doing that got 5,000 views? How did I get that many? So this is an exam review that got 5,000 views, but it might be afterwards too. And I'm just there in the corner. Yeah. I wore that shirt yesterday. There we are watching picture in picture of ourselves, everything. But yeah. Oh, thank you right there. Well, I'm very just lucky that I get to do fun stuff like this because, I don't know, it's test stream. There's so many test streams on here that I'm looking at, but it's really, really, really fun that I get to make different things, get to like have fun. And when COVID hit, I got to take. Here's the last thing I'll show you. This is the first stream I did from my apartment when COVID hit. They let me take my whole setup to my apartment. So that's why I literally have a sheet behind me and I'm just streaming from my apartment with the tablets and everything. I don't think we had space at this point, which I call the screen when I call it space. So yeah, we didn't have everything we have now that I've created. We didn't have that. The screen when you see with the flowy background behind me, I call that space. Like, let's go to space. On my little Go XL on this, it's that's space right there. So I just call it like hovering above the earth. I don't go to space. So I call this space. I don't know why. But it's all these things have evolved. We've got new things this semester. If you didn't see, this semester we added in this. We added statue. We added the Invincible this semester. We've had, sometimes I forget what we have, like Puppet Sharks. We've got Wacky Wednesday, which I didn't hit nearly enough this semester. We got Skeletor. There's so many things. And then it just becomes like a flow for the class. It's like this semester we got Morbed in. What was people's favorite? What did you like? I know that you got done the teen voice. What did people like or didn't like about the class? Like, what makes this class good? What do you like or don't like about it? This is the last question I'll ask, then I'll head off. But what would you say to me? I mean, don't, like, just whatever you think. That'll be my last question. But yeah, I really like the sound effects too. We need to put on there the degrees freedom, the ah! And I forget that I have another one on here. Another one. Goated, thank you so much. There's a lot. There's Sound of Silence. I have the sound effects are all right here. I'll show you what they are. That's all the sound effects. You might not be able to read them, but it's like doesn't matter. Notation, brother. Wow, anime sound effect. It Matters from The Rock. Mewbot, Sound of Silence. Wow, Owen Wilson. Josiah Wilkinson, great pianist. The Happy Song. Look at this graph. I never hit that one, and I gotta remember that's that one right there. That's the graph. Another one. I didn't play another one. Anything is possible. And little bits. Yeah, Jake. Office hours, especially online. Thank you so much. And it is tough. Like online office hours. I'm sorry if they were inconsistent. I was waiting for someone to be like, "Wait, I thought you were supposed to be online at this time." This was such a busy semester. Especially shout outs to the Wilson Academy. A lot of great things with CCI and Haslam College of Business. But it was so busy. It was so busy. So busy. So busy. And yeah, so it was like busy. So I appreciate it. The class itself and the material for the class, yeah, for me it's showing up cool. Yeah, I like doing the real world. Never forget playing video games in class. Compare the left, right versus hand. Yes, thank you so much, camera right there. I really enjoyed the high energy. It makes learning everything fun. You're very clear and descriptive with the material. Yeah, that's what I try to do. Is like I like to ask people a lot of times, what's your major? That's something I want people to realize is this applies to their major. Like, oh, you're doing finance. You could compare two portfolios and see which one on average is higher over a certain period of time. That'd be time series also. But I want you to feel like this class has usefulness. And so I try to pull in some examples. Mini-term is actually where I do the best, man. Those, like review-wise, not that other ones are bad, but mini-term, I really try to, it's tough in 345 to get to know everybody. But your sociology, oh my gosh, you can study everything in sociology. That is all about data. Dawn, thank you so much. Yeah, with sociology, you can study, people's habits. You can study trends of habits over time. Which of these groups hold these attitudes, or which of these groups are, changing over time. There's so much. Sociology is all about data. Look at all the research in sociology. So congratulations, Dawn. Like, that's an awesome. I did psychology, so kind of tangential to sociology. Well, I want to say a huge thank you. We'll end with this. I gotta go this way, right? Hi, everyone. Hi. Let's do a closing. We'll end the way we closed. Where's my closings? I say I have everything queued up, ready to go. My first degree goes, oh, that's awesome, Dawn. Hey, psychology, my degree. Here's our closing for the day. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.